Hello everyone. Welcome back to again a very special episode. I was away. I was not at home. I was away for 3 weeks vacation, and I missed quite a lot. And you can see like I haven't published a lot of videos, but I will be doing a lot more very soon. So stay tuned. And yeah, during this vacation, I also became uh, 4 times grandmaster on Kaggle. So that's quite an achievement. I'm very happy about it, and I'm the first one. Yeah, it's a very nice feeling. So in this video, what we are going to do is we are going to train a language model, specifically BERT, um, from scratch, and we are going to do it on TPUs. Now, recently, Hugging Face has also published a tutorial in which they show how to train language model from scratch. Using their own transformers library, and it trains on GPUs. But in this one, I'm going to show you how to do it on TPUs. It's because it's just much faster. So, and it's quite easy. It's very simple. So let's start. So first of all, I'm going to create a notebook on Kaggle, and the good thing is now Kaggle is offering TPUs 30 hours per week. So you have TPU v38. So we're going to select that one, and I hope it's visible to all of you. And we are going to, so when you select TPUs, your internet is already enabled. And I'm going to create this notebook. Okay. So what does it say? Internet access will automatically be enabled. So there is also a documentation that you can read that describes how to use TPUs with TensorFlow and Keras. So let's turn on TPU v38, and it's going to take a little bit of time, I think. Okay, so in the meantime, I'm going to describe you the dataset. So the dataset comes from this website of India. It's Oscar dataset, open super large crawled corpus. uh, and here, when you scroll down, you can see like they have data in all different languages. So for this tutorial, what I did was to download data for one of my favorite languages, Hindi, and I downloaded a deduplicated dataset. So you can also download it from multiple sources, combine all the data together to get more data. So in this one, I think we have only 11 million sentences, 11 million lines, and that's not a lot to train good BERT model. But since this is a tutorial, we are going to only do this training on a very small sample of this, and you can easily expand it to millions of samples as you want. So let's see. So the first thing that we need um, is to upgrade the tokenizers library. So pip install -u tokenizers. So this is tokenizers from Hugging Face. Quite good, quite fast. It's written in Rust and has Python bindings, and it's really fast. So we installed this one. The next thing that we have to do is downgrade TensorFlow. It's because we will be using TensorFlow BERT original source code, and it doesn't have it. It's not compatible with TensorFlow 2.0 yet, so we need to downgrade that to TensorFlow 1.15. So let's install this one. Okay, so while it's installing, this is the source that I'm using. So I have created a dataset called BERT source, which I'll be updating quite a lot of times. And here you have all the files from the original BERT repository of Google. And Yeah, it's still working. So let's wait for it to be done. Yeah, I think I should have added the datasets first, because I basically, after adding the datasets, the kernel restarts and I need to run it again. So let's just add the datasets to this kernel. We need this Hindi Oscar, and we need this one, BERT source. So let's add these two datasets. It's gonna take a while because the corpus is quite large, 10 gigabytes. So let's wait for dataset to be loaded. Seems like it's done. So we can create a new cell and say, okay, import tokenizers. Now you can see I'm not running it because I'm going to run it in the end if something happens, because it takes a while for everything. And the next thing that you need to do is the first step is to create a vocabulary from your uh, corpus, from any kind of corpus that you have. So I'm going to say, okay, I'm going to use the word piece tokenizer, BERT word piece tokenizer, implemented by Hugging Face. So this will be tokenizers dot BERT word piece tokenizer, and we need a few parameters. So we are going to keep all the parameters really very basic. So we are not going to make a lot of changes to the parameters. So you need vocab file, and this is very important. This is set to none because you don't have any vocab in the very beginning. And then you need some parameters like add special tokens to true, and you can leave the other parameters as they are. So I'm just, for the sake of seeing what the different parameters are, I'm writing them here. So you have UNK token, which is your UNK, and that's pretty standard for BERT. And then you have SEP token, which is SEP, CLS token, then you say, okay, do you want to clean the text? Now you have to look it up what it does. It cleans the text. Handle Chinese characters. So I have seen this repository corpus, and see, I have a sample of 1,000, and this is everything. You can see it's in Hindi, but there are also some Chinese characters. So I'm going to just say, okay, handle Chinese characters to true, and let's strip the accents. True, lowercase everything. Because we're going to train BERT based uncased. If you use cased, then you don't need to lowercase. So then you have word piece prefix, which is just 2 hashes. So if you remember how BERT tokenizes, and once you have initiated this BERT word piece tokenizer class, we can now train this tokenizer. So what I'm going to do is I'm going to say, okay, bwpt.train, and then you have a parameter called files, which is a list of all the files. So in our case, it's going to be just one file. So but when you're training on a large corpus, so like this one, hiddedupe.txt, the full corpus, so you need to split it to different numbers of smaller files, and that can also be done using a very simple bash command called split. And you specify, like, in every file I want 250,000 lines, and then you specify the file name .txt. So in our case it's going to be hi tube.txt, and then you can specify a prefix. So I will say Hindi underscore. And when you have that, when you have all the files, what you can do is you can do import glob, and then your file list will be glob.glob, and whatever the path to file is, and then Hindi underscore star, and you can just use the file list from here in this argument. So we are not going to do this. I'm going to leave it as an exercise for you guys. And instead, what I'm going to do is I'm going to say, okay, input slash Hindi Oscar corpus slash Hindi DTube 1000.txt. So in this file I have only 1000 because I just want the kernel to finish fast. And then you have to define a few more arguments. So like the vocab size 30,000, which is pretty standard for BERT model, but you can play around with this. You can change the size. Min frequency, I'm setting it to 3. So if I've seen a word 3 times, it's recognized. Limit alphabet to 1000. So we are going to limit the number of alphabet to 1000. We don't, and then we have special tokens, which will be your tokens like padding. Then you have unknown token. Then you have CLS token, and you have mask, which is very important. You need to have the mask token, otherwise your BERT model is going to complain. So you got all these tokens, and if you have seen BERT vocab, BERT base uncased, it also has some unused underscore tokens, so you can add them here. So let's say unused underscore 0, 1, 2, 3, but I'm not going to do that. So you can add as many unused tokens as you want if you want to extend the vocab at some point. So once you have done this one, you can now, your model will train, your tokenizer model will train, and then you can save the tokenizer bwpt.save, and I'm going to save it in slash Kaggle / working, and I'm going to call it Hindi, or we can just call it hi, but let's keep it like this, Hindi. Now the interesting part begins, where we will actually be creating some pre-training data for BERT, and that's very interesting. So let's see. So first we need to change our directory to BERT source directory, and then you can run the Python command, Python create pre-training data.py, and you have to run this command with a bunch of arguments. So input file equals slash Kaggle slash work input slash Hindi Oscar corpus slash Hindi gtube 1000.txt. And then you have a bunch of other parameters. Where do you want to save it? Output file equals Kaggle slash working slash I'm just going to say tf examples dot tf record. So it's going to create its tf record file, and then you have to supply a vocab file. So we have already generated the vocab file. Okay, let me run these steps. Do I need anything else here? I think I need the BERT base uncased. So okay, let me find where this dataset is. So here is the dataset, which is also a public dataset. So we have to add this too. So I'm going to add this data, and then I'm going to run the cells. Let's see. Okay, I can search by URL, BERT base uncased, and add this one. Okay, so yeah, it's adding the dataset, so we need to wait. Okay, so looks like it's done. So I'm just going to run these steps to make sure that everything is working fine till now. And we can also see some model files. So I update the tokenizers to version 0.4.2 and I downgrade TensorFlow to 1.15. So looks like it is done. So import the tokenizers, initialize the class, word piece prefix. So it says this is wrong. Good that we ran it. So should not, that should be word pieces prefix. And everything looks fine here. So let's train. And you can see like it trained very fast, but it's going to take a while when you have millions of samples, which you need 50 to 100 million samples at least to train a good BERT model. So you can, instead of this file, you can just choose this one. And then I'm going to save it. So it's saved to the working directory in the vocab, the output directory. So we can see here. It used to work. Okay, it probably doesn't work, but okay, we can do this. So we can do head -20, Kaggle working in the vocab.txt. Yes, obviously. Yeah, okay. So now you can see it has some tokens and all the other stuff, but we cannot see any Hindi characters. So I'm just going to do the tail. Yeah, okay. So you can see a lot of Hindi words and some English words mixed stuff. That's pretty good for us for now. And it's a very small sample of the corpus. So now we are going to switch the directory to BERT source. And just to make sure, what we have here is all these files from original repository of Google BERT. And now we have to run the script create pre-training data.py, and we were on this step, vocab file. Now your vocab file is /kaggle/working/hindi vocab.txt. That's your vocab file now. And then there are a bunch of other arguments to lower case. So this is true, BERT base uncased. And then you have max sequence length, so 128. That's good enough for us. You can also set it to 512. Then we have max predictions per sequence, so the maximum number of predictions it's going to make for every sequence for masking. And masked LM probability. So what is the probability of masking a word in a given sequence? And then you can set some kind of random seed, 42. And then you have a dupe factor. I'm going to set it to 5. And if you want to learn more about these different parameters, you have to see the original repository. So once you have this, it's going to create this file tfexamples.tfrecord in your output. So let's create that file. Let's see how much time it takes. It should not take much time. It's quite fast. But if you have millions of samples, then it's probably going to take a while. Key error sep. Bad UNK CLS mask. We didn't add a sep token. And yeah, that's why it's very important. So let's run this again. Okay, yeah, so yeah, it gives me an error. So what I'm going to do is I'm going to restart the kernel. And then we have to run all the steps again. So, okay, so all the steps have rerun. And then we go to this one, see the different files that we have, and then we create the pre-training data process again. So let's see how it goes now. Okay, it's reading, and yeah, it's a lot of verbose. So has it done? Yeah, it's done. So it has created the pre-training data. So now you should be able to see it here, TF record. Now a very important thing here is you have to create multiple TF records when you split the file. So I've shown previously how you can split the file and how you can then train the tokenizer. So once you have multiple files, once you have tens of corpus files, you have to run this step for all of them individually. And you can just change. So instead of tf examples, you can say, okay, tf example 1, tf example 2 .tf record, and like that. So you have to run it for different input files, and the output file names should also be different. Once you have all of them, you can now start training on TPUs. But there is one problem. It's not a problem, but TPUs will to train on TPUs, your data must be stored on GCP bucket. So once you have these files, you can download them or create or just push it to bucket using the same kernel, or you can directly save this one instead of this, you can just write s3 slash bucket name. I hope it will work. I'm not sure. But I have created a bucket, and you can see I have this tf examples.tf record here in my bucket tf language model. And I've also created a directory. So I hope it's much more visible now. So I have also created a directory called model slash, where I'm going to save the model checkpoints and the model itself. So now when this is done, we can now start training the model. And to train the model, it's also very simple and easy command, and we're just going to use everything from the original original BERT repo. So I'm going to say python run pre-training .py, and you need a bunch of arguments. So input file. So now everything goes from Google Cloud Buckets. So gstf lang model slash star.tf record, and then you have output directory, that will be gs. So I've created the output directory called model slash, so I'm going to use that. Do train and to true, do eval to true, and you need to supply one BERT config file. So you can use any kind of config you want. It's just a JSON file, and yeah, that's pretty cool. You can train any kind of BERT model. So my BERT config file is in Kaggle slash input slash BERT base uncased slash config.json. So this is the config file for BERT base uncased. You can see it here, config.json. So a standard config file, default one. And then we need to define some things like batch size, train batch size. You can adjust it, and train max sequence length to 128. We had a max sequence length before to 128, so we need to use the same. Max predictions per sequence to 20. These are the default parameters, so nothing very interesting over here. Num train steps to 20. You need a lot more training steps when you're training the actual model. So num warm up steps to 10. And learning rate, you need to define a kind of learning rate to 2e minus 5, let's say. Then we have the interesting part, use TPU to true, and you also need a TPU name. So once you have enabled TPU, once your accelerator you're using here is TPU, you can get the TPU name from the environment variable called TPU underscore name. So $TPU underscore name. And then we can fire up this part of the code. Let's see what happens, if it works or not. So it has given me some errors. Do I have errors here? Yeah, it looks like. Yeah, GD should be GS. Um, let's see what happens now. So it seems like it is working. No, it's something happening. Input files. Okay. Um, let's see. Batch size 32. Yeah. Okay. So number of TPU cores 8. Number of TPU worker 1. So you have 8 TPU cores, and you can see here. That's pretty cool. 0 to 7, and now it is training your model on TPU. So why do we use star here? Because you have to split the file into chunks, so you train on all chunks. And you can see the loss is very high, and it has already finished because it's a very small data set. And now we go back to our bucket and see here. Okay, it has the checkpoint, it has evaluation results, it has the graph, model checkpoint, and everything. So one thing that I'm doing here is I've made read and write access to this bucket public, which I'm going to revoke right after I publish this tutorial. So I didn't spend time figuring out how to access these buckets and write to these buckets using Kaggle kernels, but you guys are pretty smart, and I hope you can do that. And if you figure it out, also write in comments so that it's helpful for others. And is there something that I'm missing? Okay, now you have the model, and Kaggle kernel allows you to run TPUs only for 3 hours. You need so if you need to keep training, there is a init checkpoint parameter, so you can use that. You can initialize from, so you have to specify like this which checkpoint you want to start from, and then you will have the train model here. And the next thing that you can do is go to transformers from Hugging Face, and you can convert the TF checkpoint that you have created to PyTorch, so you can use the school library, or you can just use it as it is. So yeah, that's the tutorial, and it's quite easy. I'm really surprised that nobody shares these kind of things when it's quite simple, but it took me a while to figure everything out. So this kernel will be available for you to take a look at. It will be available in the description box below. And I'm also writing a book called Approaching Almost Any Machine Learning Problem. And if you want to be the first one to know about the book, there's also a form in the description box. You can fill it out. It's quite simple, only 3 fields. And let me know in comments how I did, if I missed something, if I did something wrong, how I should improve, and I'll do that. And wait for more cool videos. And thank you very much.